This is an introduction video of the inverter I have. I've been wanting a good size pure sine wave inverter, and this one was something I could afford. It seemed to have good um, ratings, but the big thing is, they would help with repairs. They have repair kit and a little brochure on checking the MOSFETs. The name is Reliable. Made in China and China design. I don't know if selling a repair kit is a good idea, kind of like buying a car and say, by the way, you might want some spare parts. But I like the right to repair, and I did peek through the vents, and I could see the component numbers were still on the components. I hate it when you buy some electronics and they black out part numbers. I think if you buy something, you should be able to work on it. This is just an introduction, but we'll look at the outside with a scope, the signal, and signals on the inside with a scope. And I can save those and put them on to make a topic. It's kind of goofy the way they do it. I can understand the output. On the hot leg, you have one pulse, and on the neutral leg, which normally is ground, you have the other low end pulse, negative pulse. So we'll look at that with a scope on the next video, but that's important to understand. One thing, it's kind of goofy color coding, and then the other thing is that pulse on the leg that should be neutral. And if you hook that up to a ground, you're going to short this out. And that's probably why they have it so you can replace the MOSFETs, because people wire it up wrong or don't understand that. So we really need to understand that before we go any further. I have been using it with the router and sanders, and the fan has never kicked on, but I really haven't run it that much. This is 24 volt. I wanted to go to 24 volt as a kind of a compromise. They can configure this to do 12, 24, 36, 48, 96 volts. And they just changed some components, so that'd be kind of interesting to figure out how they do that. I did talk to them, they wouldn't tell me. They said, well, you have to change your resistor, but they're letting you change MOSFETs and the resistors to go with the MOSFETs in case you short it out. So the main thing is, as long as there's no programming, you have to change. It would be neat, like if I go to a 48 volt someday, that if I could change that. I just used welding cable because I had it, and I really like welding cable. It's flexible and good gauge. I did try one of these breakers, see how they work out. It's the kind where it's not the popular one. They have this tiny little 1/4-inch bolt, and you just put an eyelet on it. This, you can stick the whole heavy wire in, and there's a barrel in there also, and you tighten it up. And we'll see how that works. For the ends, I don't like buying those ends. They're expensive, and it's always the wrong diameter hole. So I just take a copper pipe, and then I squish one end in the vise and drill a hole on the flat side. And I've had this for about 5 years. It works really well. You just crimp it onto the wire, stuff the wire in here, and you just hit this with a ball peen hammer. Oh, I give it 6 nice raps, not too hard. You can feel when it's time to stop. And that works really well for me. For me, might not for somebody else. So that's the next video. We'll pull this out. I can't pull it out because the wires are hooked up in the back, but I can pull it out later, and we'll take a look at it and look at some scope. Probably first we'll do the output and understand why you can't hook that neutral to ground in any way. I don't know if that'll be a safety problem like for some hand tools, but it works for me. I don't care. I think that's a good start for now. Talk to you later.